Welcome, Algebra class, to your personal learning experience, aka Mr. Chow Time. Here we go. Lesson 9, Writing Equations. Okay, so the key concept here, the main idea, is that when you're confronted with a situation and there is something unknown that you have to evaluate for, you need to identify the unknown for which you are looking for an answer in order to assign a variable to it. Then you're going to write a sentence as an equation. And an equation, for those of you who've forgotten, is an expression with an equal sign and then another expression. Basically, it's two expressions connected with an equal sign. These words is the same as, is identical to. These phrases can sometimes help you to know where to put the equal sign. Let's take a look at an example. The KAS cross-country team is running a race at Isho International School. The length of each lap times the number of laps is the length of the race. So, what are we trying to find here? Well, it doesn't actually explicitly say, but what we're trying to find is the total race length. So, what are the variables? What are the things that we don't know? Well, we don't know the length of each lap, right? So we can call that L. Length of a lap. And then another thing we don't know is the number of laps. So we can call that N. Number of laps. And then the final thing that we don't know is the total race length. So we'll call that T. So where is the equal sign in the situation? Well, the length of each lap times the number of laps is the length of the race. Here we have our three variables. Length of each lap times the number of laps equals the total race length. We've done it. Moving on. Translation is important. Being able to translate a situation into a mathematical representation is a really, really important skill. In fact, one of the main skills of the entire pre-algebra and algebra course. 2 years devoted to this one skill. So, you get a situation, because remember, all math represents some real life thing that is happening. And we want to be able to represent it with math, right? And math is things like numbers, operations, so on and so forth. There's other things too, shapes sometimes. Anyway, being able to turn a real life thing into numbers and operations is kind of the goal here. For example, there are 87,000 flights per day in the US. In how many days will 261,000 flights have occurred in the US? Okay. So what do we need to find out? In how many days? How many days? This is a pretty big clue. This is what we want to find out. So we can just go ahead and assign our variable right away. D equals the number of days. Right? So we also know that there's 87,000 flights per day. This word per is a pretty important word. Per is a clue that for each one of these we have one of these. Right? So like one, or not each one, but each 87,000. So for example, 1 kilometer per hour means that for every 1 kilometer for every 1 hour we travel 1 kilometer, right? In this example, for every 87,000 flights, it's 1 day. So in 2 days, it would be 174,000 flights. And it's asking in how many days will 261,000 flights have occurred in the US. So we know from this wording here, per day, that we're going to multiply the 87,000 by D. And in some number of days, we don't know how many yet, we're going to get 261,000. Then we just solve for this equation, right? Divide both sides by 87,000, and you get D equals 3. D equals 3. In 3 days, there's going to be 261,000 flights, according to the situation. Okay. Here is our first vocabulary word for the lesson, formula. A formula is a rule for relationship between certain quantities, often with variables to represent numbers and form general rules. So you have all seen formulas before. The area of a rectangle is the length times the width. The volume, I probably shouldn't write out the whole word. The volume for a cube is the side length cubed. Anyway, these are formulas. It explains a situation. Uh-oh, my pen just died. There we go. It explains a relationship between these three variables, right? And they are in a relationship, as you can see, because there's an equal sign, there's expressions. So as you change one, the others will change as well. Okay. Let's look at an example as we do. The area of a triangle equals the product of 1/2 of the length of the base and the height. Write this rule as a formula. Okay. The area of a triangle equals the product. Product is the end result of multiplication of 1/2 of the length of the base and the height of the triangle. Okay. So we can start plugging in some variables here. Let's start with A. This is the area of a triangle. We'll use L for length of the base, and H for height of the triangle. Okay. So now let's look back at the words. The area of the triangle equals. So we can just start right there. A equals. And then the product. Product means to multiply, right? And which two things are we multiplying to get the answer of this thing? The product of 1/2 of the length and the height. 1/2 the length of the base and the height. Yeah. I'd like to clarify something before I move on, actually. Usually, the base is written as a B. And I used L, which is not how you usually do it. But I just wanted to show you that whatever it is that you want to use in your formulas is fine, as long as you define the variable in that situation. So most often, we use the letter A for area. But there's no rule that it has to be area. There are some rules, like this is always pi. This is never anything other than pi, right? And there are some that are just kind of set. But in general, and in this class, as long as you define the variable in your problem, then I will let you pretty much use anything that you want. Okay. Let's try it again. In a right triangle is a triangle with one 90-degree angle. The square of the measure of the hypotenuse is equal to the sum of the squares of the measures of the legs A and B. So the square of the measure of the hypotenuse, square, this is a operation, right? This is telling us to do some math of the hypotenuse C. So here we've been told to use C, right? So we're going to use C. C is the hypotenuse. Hypotenuse is equal to the sum. Here's another operation of the squares of the measures of the legs A and B. A and B are both legs. So we have our variables, and all we need to do is write our equation. So square of the hypotenuse C, so squared looks like this, is equal to the sum. That's a addition, right? Sum is the end product of two things being added together. The squares of, so we have two squares, A and B. A squared, B squared. And there you have it. I feel like we just did this, right? Okay. Sometimes you are given an equation and you must be able to translate it back into a sentence. This is less common, but it still happens. Okay, so let's look at an example. Here we have an equation that's given to us. 15 equals 25u squared plus 2, and we're being asked to translate it back into a sentence, right? Okay. Oops. Here we go. So, I guess the easiest way would just be to go left to right. 15 is equal to the, and then we have a product here, right? Two things that are being multiplied together, to the product of 25 and u squared and then we have an add 2. And that's it. Here we have a verbal equation of the algebraic equation that we were given. So let's do that one more time just to be sure that we know what's going on. Here we have the equal sign kind of further along. So we'll start here again, left to right. So this is 3 halves, right? 3 over 2. 3 halves times r minus t squared is the same as 132. I would just like to remind you that this number is 132, not 132. And really what's going on here is that when you use the word and, that usually signifies a decimal point. So 100 and 32 is kind of like this, whereas 132 is this right here. So keep that in mind. I know when we're talking, we can use the and that's fine. It's just not technically correct. So, just keep that in mind when you're writing verbal equations. Oopsies. I'm always doing that. Creating a problem from information helps you think like a problem solver. Sometimes having practice going in the opposite direction will help you do the skill that is the actual skill that you're using. So let's take a look at an example of that. Here we're given our variables, and the variables are defined for us, and then we're given an equation, and we're being asked to write a little situational story out of this. And so I've already done that because it just takes me too long to write all this. So for example, we have C, which is the amount of time that Mr. Chow drove on a road trip. And then we have C plus 4, which is the amount of time that Mr. Fiddler drove on a road trip. I guess we can also have said that these are the same road trip. So 2C plus C plus 4 equals 28. So how can we write a situation out of this? Well, Mr. Chow and Mr. Fiddler went on a trip to Kenting and took turns driving. During Mr. Fiddler's turn, he drove 4 more hours than Mr. Chow. Mr. Chow took 2 turns. That means he drove 2 times. And Mr. Fiddler took 1 turn. Together, they drove for 28 hours. So as hopefully you can see, even though I've scribbled all over this, you can see that this equation here represents the situation. Together, they drove for 28 hours. That's the equal sign and the 28. So, in your story, you can ask a question like, how many hours did Mr. Chow drive? And that signifies this first variable here. See how the entire equation is written based on the variable C instead of the variable F? I mean, we could have written like F is the amount of time that Mr. Fiddler drove, and then Mr. Chow drove F minus 4, right? Because he drove 4 hours less. And that's true, but because the variable that we're isolating for is C, then the final question that you should be asking should have to do with that variable. Okay. I hope that one wasn't too long. Have a good night.